Have you ever wondered what the darkest thing in the universe is? You might think of a black hole, a place where gravity is so strong that not even light can escape. But what about right here on Earth? What's the darkest material humans have ever created? Get ready to have your mind blown. Today we're diving deep into the world of super black materials, substances so dark they make regular black look like a light shade of gray. The current champion of darkness is a material called Vantablack. The name itself sounds like something out of a sci-fi movie, right? Vanta stands for vertically aligned nanotube arrays. That's a mouthful, but the concept is fascinating. Imagine a forest, but instead of trees, you have billions and billions of tiny carbon nanotubes, all standing upright, packed tightly together. These nanotubes are incredibly thin, about 10,000 times thinner than a human hair. When light hits this forest of nanotubes, it doesn't just bounce off like it would with a normal surface. Instead, the light gets trapped. It enters the gaps between the nanotubes and just keeps bouncing around, getting absorbed and converted into heat until almost none of it can escape. How much light does it absorb? Vantablack absorbs an astonishing 99.965% of visible light. That is so close to absolute black that our brains can't really process it. When you look at an object coated in Vantablack, you don't see its shape, its texture, or any of its features. All you see is a void, a flat two-dimensional hole in reality. It is like looking at a piece of the night sky that's been cut out and pasted onto an object. Let me give you an example to really illustrate this. If you were to take a crumpled piece of aluminum foil, you'd see all the crinkles, the shiny parts, the shadows. It's a very textured, three-dimensional object. Now if you coat that same crumpled piece of foil in Vantablack, all of that detail disappears. The crinkles, the folds, everything vanishes. It looks completely flat, like a black circle cut out of a piece of paper. It's a bizarre optical illusion created by physics. Vantablack was developed by a British company called Surrey Nanosystems back in 2014, and it immediately captured the world's imagination. But here's where the story gets a little controversial. An artist named Anish Kapoor secured the exclusive rights to use Vantablack for artistic purposes. This caused a huge stir in the art world. Imagine being told that only one artist in the entire world is allowed to use a specific color. Other artists were, to put it mildly, not happy. This led to a bit of an art war. In response, another artist, Stuart Semple, created his own line of pigments and made them available to everyone, except Anish Kapoor. He created the pinkest pink, and when you bought it, you had to legally agree that you were not Anish Kapoor and wouldn't let the pigment get into his hands. He then went on to create his own super black paint, called Black 3.0, which is also incredibly dark and available to all artists. While not quite as dark as the original Vantablack, it's much more accessible and creates a similar mind-bending effect. Now you might be thinking, what's the point of creating something so black? Is it just for art and cool visual tricks? Well, not at all. The potential applications for these super black materials are incredibly exciting and important. Think about space exploration. Telescopes like the Hubble need to capture the faintest light from distant stars and galaxies. Any stray light bouncing around inside the telescope can create noise and ruin the image. By coating internal components with a material like Vantablack, scientists can absorb that stray light, leading to clearer, more detailed images of the cosmos. It's like giving our telescopes super-powered sunglasses. It's also used in calibration for cameras and sensors. To make sure a camera is capturing colors and light levels accurately, you need a perfect black reference point. Vantablack provides that. It's the ultimate benchmark for darkness. There are also potential uses in solar energy. A more efficient light-absorbing material could lead to more efficient solar panels that can capture more energy from the sun. The military is also interested, of course. Imagine using a super black coating for stealth technology, making aircraft or satellites almost invisible to optical detection, especially at night. It could completely change the game in camouflage. But the story doesn't end with Vantablack. The race for black is ongoing. Scientists at MIT have since created a material that's even darker. In 2019, they announced a new material, also made from vertically aligned carbon nanotubes, that absorbs an incredible 99.995% of incoming light. That's 10 times darker than Vantablack. The way they discovered it was almost by accident. The team was trying to grow carbon nanotubes on different materials like aluminum to enhance their electrical properties. They noticed the resulting material was surprisingly dark, and when they measured it, they were shocked. They had unintentionally created the new blackest black. To showcase their discovery, they coated a 16.78 carat natural yellow diamond, worth about $2 million, with the material. The diamond, one of the most brilliant and light-reflecting objects you can imagine, completely vanished. It was transformed into a flat, black, diamond-shaped abyss. The effect is truly jarring and highlights just how powerful this technology is. So what does the future hold? Researchers are constantly pushing the boundaries. Can we ever reach 100% light absorption? Theoretically, it might be possible, but it's an incredibly difficult challenge. Every tiny imperfection in the material can cause a minuscule amount of light to reflect. But scientists are getting closer and closer. These materials are more than just a scientific curiosity. They challenge our perception of the world. They show us that even something as fundamental as color and light can be manipulated in ways we never thought possible. They force us to ask what we're really seeing when we look at an object. Are we seeing the object itself, or just the light that bounces off it? When you look at something coated in the blackest black, you're experiencing a true absence of reflected light. It's a little piece of nothing, a void you can hold in your hand. It's a reminder that there are still so many wonders to be discovered, even in something as simple as the color black. The quest for ultimate darkness is really a quest for ultimate control over light, and that's a quest that could illuminate our future in countless ways. From helping us see deeper into space to creating new forms of art and technology, the darkest materials on Earth have a surprisingly bright future. It's a perfect example of how science can be both incredibly practical and beautifully mind-bending at the same time. So the next time you see the color black, remember that what you're seeing is just a shadow of true darkness. The real thing is a forest of nanotubes, a trap for light, and a hole in reality that we created right here on Earth. Thanks for joining me on this journey into the void. If you found this fascinating, make sure to hit that like button and subscribe for more deep dives into the amazing world of science and technology. Let me know in the comments what you would coat in Vantablack if you could. Until next time, stay curious.